And the challenge to teach. We talked about the transit, we talked about parallax, we talked about how to view the transit. Go to VenusTransit.nasa.gov. Even one of my students, hopefully they're watching today, is holding a transit party. And we talked about what else is
more important. Back in February, we were out here testing for the VenusTransit. You were actually Skyping with your class about the transit.
That's right. We couldn't do this in 1882, but we could. But we did that in 2004. We can do it now. We're a connected planet now. So information gets around real fast.
What assignment we had? Wasn't part of extra credit if
all your students can go to the website, our website, NASA Edge, www.nasa.gov/NASA Edge, download all 90+
episode of NASA Edge as part of their grade?
Perhaps I did allude to that. I'll get back to you on that.
Hey, we have another question from our viewers. This one's from Anna. Can you explain why the transit appears at the top or the bottom of the screen?
Well, it really just depends on how the telescope that the camera is attached to is oriented, and for a while there, I guess, we had some different telescopes with different cameras and filters. They were oriented different ways, and I think that was cleared up now. Is that correct, guys?
That is correct.
Okay, so that's really why it was changing, because it kind of depends on how you're facing when you look at it, how these telescopes were turned when they were looking up at the sun. So that was really the reason.
This is very good in the venue at Mauna Kea because we're actually able to see the transit from this location. But Lou, tell us, in 2004, that wasn't possible.
That's right. It turns out that it's not an integer number of days between transits. So the Earth has turned a fraction more or less between these transit pairs. And in 2004, for example, on the East Coast, where I live, in 2004 we saw the transit in progress as the sun was rising. But in 2012, on the East Coast of the United States, we're seeing the transit from its beginning as the sun is setting. Some places on Earth won't see the transit at all. So it just depends on
for reasons involving the laws of physics, goes faster around, right? And so its transit of the sun, for geometric reasons and its speed of orbit, will actually